Alrighty. Happy International Mountain Day. Yeah. Yeah. That's what it is today. I don't know, it was designated by the UN in 2003 to raise awareness about the importance of mountains. Alright. Formative tomorrow, okay? And then a test a week from today. So, formative tomorrow, test a week from today. Okay? So, let's get her started with a warm-up. Solve that over first lap unit circle. All right. So, first thing I would do here is, anybody? Okay, we can bring the 2 over right away. So then that's going to become sine of x plus 2 plus, negative sine of x plus 2 plus 3 cosecant of x equals 0. Okay, like it. Next. I would love to do that, actually. I heard somebody just whisper that they did it first. Is that what somebody said? Yeah? And that's fine. I would have done it first, too. Okay. Yep. I would have done that first also. But it works doing it second also. Next. Multiply everything by sine. So I'm going to multiply here by sine, here by sine, here by sine, and here by sine. Okay? So then that gets me negative sine squared of x plus 2 sine of x plus 3 equals 0. Okay? Me, personally, I'm going to multiply through now by negative 1. Multiply the whole equation by negative 1. Because then that's going to give me positive sine squared of x minus 2 sines of x minus 3 equals 0.
Do you have to do it that way, or can you just keep it negative and still factor?
You can, but it's goofy because then I always like having my squared term be a positive value. So yeah, but you still can by all means. Yeah. Factor this out. We know we're going to have sine of x and sine of x. 2 numbers that multiply together to be negative 3 and add to be negative 2 are negative 3 and positive 1. So then this becomes sine of x minus 3 equals 0. So that is where sine of x is equal to 3. Where in the first lap of the unit circle is sine equal to 3? Never. Nowhere. Nada. Zilch. Nothing. Okay? So that one's just gone. Yes, Ethan?
Can you do it without multiplying everything by negative 1?
Yes. It's a little harder factor, but yes, you can. Sine of x equals negative 1. Where is sine equal to negative 1? Just at 3 pi over 2. So we get that. Good? Now, I will tell you this for tomorrow and for next week, Thursday. Reading directions is kind of crucial. Okay? because of kind of what you had earlier today, or earlier in this one. Okay, because this was a solve, that means we had to get an answer. If it said prove, then we could only work one side. Okay, because it's a solve, we can work both sides. If it says prove in the directions, then we can only work one side. Okay, so we got to be mindful of those wordages in the directions for each problem. Okay. This one is a prove, so we can only work one side. So now we're going back to yesterday's rules and regulations and all that fun stuff. Okay. Which side looks more complicated? Definitely the left, right? Okay. So that's the side that we want to work. We want to work the left side specifically. Okay. Please, please, please don't fall into the trap of this is cosine squared minus sine squared. Okay, where you just square each part and then move on. It is not. Okay? If we think back to regular old algebra, x minus y squared is really x minus y times x minus y, which is x squared minus xy plus y squared. So that's x squared minus 2xy plus y squared. Likewise, if it were plus, then this would be plus, this would be plus, plus, and plus, and plus. Okay? Okay? It's not just square each term and move on with your life. And there's that middle term, those middle terms that come into play. So, cosine of t minus sine of t quantity squared then would become cosine squared of t minus 2 cosine of t sine of t plus sine squared of t. Cosine of t plus sine of t quantity squared then would be cosine squared of t plus 2 cosine of t sine of t plus sine squared of t. It's that. Yesterday someone asked me, should we write then equals 2 after it? And I said no. And here's why my rationale for the no part. Okay? Because if you write equals 2 now, then you're gonna, that temptation to work both sides is still there. Okay? And we can't work both sides. So don't even write it, just get it equal to 2. Okay? If I'm looking at this, I see a minus 2 cosine sine. I see a plus 2 cosine sine. What happens with those two? That cancels out. Okay? So then that leaves me with cosine squared of t plus sine squared of t plus cosine squared of t plus sine squared of t. Now what? No. No. I mean, you could, yes. In both of those, you could, yes. Which one am I going to use? Number 7. And what am I going to? Which part of that am I going to use? Yep. So this right here is 1. This right here is 1. Okay? We could have gone your way would be going to get to the airport, going out to Marathon. it's not that big of a detour, but it is a detour. Okay, we can just go right to it. Okay. Likewise, Mace, yours would have been going to Marathon too. It wouldn't have been that big of a detour, but it still would have been a detour. Okay? And so then that gets me 2, which is what I needed it to be. Okay. Go for it. If I'm working left side, I'm going to multiply by the conjugate of the denominator. That then would give me cosine of x times 1 minus sine of x all over 1 minus sine squared of x. 1 minus sine squared of x is cosine squared of x. One of the cosines at the top cancels out one of the cosines in the bottom. That cosine cancels out one of the cosines there, leaving me with 1 minus sine of x over cosine of x, if I did that side. If I'm doing the other side, I would multiply by cosine of x over cosine of x. That would give me then cosine of x times 1 minus sine of x all over cosine squared of x, which then I could change cosine squared into 1 minus sine squared, which then I could change into one minus sine, 1 plus sine. Then my 1 minus sines cancel each other out, leaving me with, go off to the side here, cosine of x over 1 plus sine of x. Questions, comments, concerns, clarifications? Try that one. Whew. Which side? Right side? Okay. All right. I'll go with the right side. So if I'm looking at the right side, I would look at this and I would say to myself, there's a sine squared in there. And if I factor out that sine squared, I get a 1 minus sine squared. Right? 1 minus sine squared is 1 minus sine squared is cosine squared. cosine squared times cosine is cosine cubed. So then this is just sine squared of x cosine cubed of x, which is what we needed. Left side, if you would have chosen that one, I would have broken up cosine cubed into cosine squared cosine, and then changed cosine squared to 1 minus sine squared, and then distributed. Go for it. I feel as if everyone should have chosen the left side to work. Yeah. Okay. All right. If I'm looking at the left side, my numerator on the left side factors to be 1 minus cosine times 1 plus cosine, 1 minus 4 cosine.
Wouldn't it be 3?
No, it would be 4. Because these two here
Oh, okay, I see.
have to multiply together to be negative 4 cosine squared.
I see.
And then the outers and the inners have to add to be negative 3 cosine. Okay? At the same time, I would make the denominator 1 minus cosine squared. Now, we can make 1 minus cosine squared be 1 minus cosine 1 plus cosine. And then our 1 plus cosines from top and bottom both drop out, leaving me just with 1 minus 4 cosine of x on the top and 1 minus cosine of x on the bottom. Which is what I need. If you would have chosen the right side, you would have had to have multiplied by the conjugate, 1 plus cosine over 1 plus cosine. And then you would have gotten this blue on the top and the pink on the bottom. Then you would have multiplied this out to be 1 minus cosine squared, which then you would have had to change back to sine squared while you also multiplied out the blue. Okay? Go for it. So the debate is, which side's more complicated, right?
Yeah.
Which side looks more complicated? The right side being more complicated? I like the left too. Fractions are always much more complicated. Yeah.
Then you can just do the 1 times 6. Wait,
Okay, that's good.
what's that?
Because so what did you do first?
I did the right side.
Oh, you did the right side? Okay. All right, well, let's go left side here now. Okay? So if I'm working left side, I would go 1 minus cosecant over 1 minus cosecant. I almost did CCC there. If I do that, On top I get cotangent squared times 1 minus cosecant. On the bottom I get 1 minus cosecant squared. Agree with me on that? Okay. Do I have an identity for cosecant squared? Yeah? 1 plus cotangent squared? Okay. So then that is going to be cotangent squared 1 minus cosecant all over 1 minus 1 plus cotangent squared. Right? What does my numerator become? Or excuse me, my denominator. Sorry, I said numerator. What does the denominator become? No. What does the denominator become? I didn't hear what you said. No. Didn't distribute. The negative would have to go there, and it would have to go there. So it becomes negative cotangent squared. Right? 1 minus cotangent squared is just negative cotangent squared. Yeah?
Well, wouldn't you distribute the negative first and then multiply by the 1? No.
I'm not multiplying by a 1.
The one
I
that
distributed the negative.
Yeah.
And I got 1 minus cotangent squared,
Okay, that makes sense.
which is just negative cotangent squared. Okay? Now what can I do with it? Cancel out the cotangents. Okay? So if I cancel out the cotangents, I'm left with negative 1 times 1 minus, oops, I almost did it again. For some reason I'm struggling to write down cosecant today.
Why is negative 1 not in the bottom?
So if fractional logic says my fraction is equal to negative 1, that could be negative 1 over 1, that could be 1 over negative 1, and that could be negative 1 over 1, right?
Yeah.
Huh? So I don't need it on the bottom.
So
Huh?
you kind of pick and choose where it would go. In a sense.
The negative sign, yes.
Yeah, the negative sign.
Now, if it were not just 1 on the bottom, then we would still have to have that fraction.
But just because it's 1.
Yes. Okay? Now what? Distribute the negative 1, right? Okay? So if I distribute the negative 1, that's going to become cosecant minus 1. Right? Okay? Now, let's take a peek at the other side, because we can always do that. We can't work the other side, but we can definitely look at the other side. If I'm looking at the other side, I see that I need to factor out a cotangent. That's what this is right here. So let's factor out a cotangent out of this. Okay? Yes, I know it's cosecant. Okay? But let's factor out cotangent. So in my brain, now this next term right here is going to be cosecant divided by cotangent. Right? Because when you factor something out, you're dividing by it. Okay? So keep, change, flip says cosecant is 1 over sine. Cotangent is cosine over sine. When I flip it, it becomes sine over cosine, which is what? Secant.
So did we just pull that cotangent out of thin air?
No, we looked at the other side.
That's exactly what we did.
We looked at the other side and said we need to have a cotangent out in front of a set of parentheses. So let's factor out a cotangent. Okay? When we factor, we're dividing, right?
Yeah.
Okay?
I just thought it had to be there in order for you to factor it out.
No. No.
Okay.
You can, so let me go simple like algebra type 1. Okay? Mace? So if I have 2x plus 7. Okay? If I want to factor out a 3, right? Okay? That means I would have a 3 out in front, and then I would have to divide those terms by 3. Because then it would be 2x over 3 plus 7 over 3. Right? So that when I distribute this 3 back in there, I'm back to 2x plus 7. With me?
Yeah.
Same thing down here. If I take cotangent times secant, I get cosecant. Okay? Now we got to do the other one. Now I got to factor out I got to take 1 and I have to divide it by cotangent. You should know by now that 1 divided by cotangent is tangent, okay? Because it's the reciprocal of cotangent, which is tangent. And if memory serves me correct, that is what we needed. Yeah. Yeah. The point of that one is it helps to look. You can't work the other side, but it helps to look at the other side. Okay? I remind you, tomorrow is a formative. Four-question formative. Okay? 4 questions on your formative. And a week from today is your test.